So, have you ever stopped to wonder what's actually going on behind the scenes of your favorite apps? It feels like magic, right? Well, today, we're going to pull back that curtain. We're going to demystify the cloud by breaking down 12 core concepts from AWS, that's Amazon Web Services, that pretty much power our entire digital lives. Let's dive right in.
Okay, picture this. You've been working on an app for months. You finally launch it, and boom! Overnight, it just explodes. Millions of people are signing up. I mean, that's the dream, right? But it can also become a total nightmare, really, really fast. How on earth do you handle that insane spike in traffic without your servers completely melting down and your app crashing?
Well, the answer lies right here, in these 12 concepts. Now, these aren't just buzzwords that tech people throw around. Nope. These are the actual fundamental building blocks that engineers use to build applications that can handle that kind of massive viral success. They're the toolkit for building something strong and scalable.
So to wrap our heads around all this, let's think of a modern app as a giant digital skyscraper. First, we're going to look at the front door, how it manages all the crowds. Then, we'll explore the resilient backbone, which is like the internal communication system. And finally, we'll go down to the smart engine room, the power source that keeps the whole thing running and growing.
All right, first stop, the front door. This is all about how your application says hello to the world. When you have a million users all trying to get in at once, these concepts are your crowd control. They make sure everyone gets in smoothly without causing a total digital stampede.
The very first thing we need is load balancing. You can think of it like a super efficient traffic cop standing right outside our skyscraper. Instead of funneling every single person through one door and creating a huge bottleneck, the load balancer intelligently directs all that incoming traffic across a whole bunch of different servers. This keeps any one server from getting overloaded and makes sure the experience stays fast and smooth for everybody. Next up is the Content Delivery Network, or CDN for short. Now, a CDN is kind of like having a global network of tiny warehouses. It takes all your app's static files, things like images and videos, and stores copies of them in locations all around the world, closer to your users. So if someone in London wants to see a picture, it gets sent from a server nearby, not all the way from California. And the result? Stuff just loads way, way faster.
So, if the load balancer is the traffic cop outside, the API gateway is the main reception desk right inside the lobby. It's the single, secure entry point for every request your app gets. It checks everyone's credentials, figures out what they need, and then points them to the right department, or in tech terms, the right microservice, inside the building. It's the ultimate organizer and gatekeeper.
But what about keeping things fair once people are inside? That's where rate limiting comes into play. Think of this as the security guard standing at that reception desk. It makes sure no single user can just hammer the system with a bazillion requests all at once, whether they mean to or not. By setting a fair limit, like, say, 100 requests a minute, it protects the whole system from being abused and makes sure there's enough capacity for everyone.
Okay, so we've managed the crowd at the front door. Now let's venture deeper into our digital skyscraper and check out its resilient backbone. This is all about how the different departments, all those internal services, talk to each other reliably, especially when things start getting really busy and chaotic.
First up in the backbone is the message queue. This is basically the skyscraper's internal mailroom. So instead of one department having to run over and hand-deliver a message to another and then wait around for a response, it can just drop a message off at the mailroom. Then the other department can pick it up and handle it whenever it has a free moment. This is huge because it lets all the parts of your app work independently without getting stuck waiting on each other.
And building on that mailroom idea, you have the publish-subscribe model, or pub/sub. If a message queue is like sending a direct letter, pub/sub is like blasting out a company-wide memo. One service publishes a message to a channel, let's call it the new order channel, and any other service that's subscribed to that channel instantly gets a copy of the message. It's a super powerful way to do one-to-many communication.
Now, what happens if one of those internal services starts to have a problem? Well, that's what the circuit breaker is for. And this is a really clever safety feature. It works just like the circuit breaker in your house. If there's a power surge, it trips to stop all your appliances from getting fried. This does the same thing for software. It detects when a service is failing and temporarily stops sending it requests. This prevents one small problem from cascading and taking down the whole system. It's a lifesaver.
So, with all these different services spinning up and down and moving around, how in the world do they find each other? That's the job of service discovery. Just think of it as a live, self-updating employee directory for your app. When one service needs to talk to another, it just asks the directory, "Hey,
Where can I find the user profile service right now? And it gets back the current, correct address. It's absolutely essential in this dynamic cloud world. All right, we've secured the entrance, we've built a rock-solid communication system. Let's head down to the basement. We're going to the Smart Engine room. This is where the real power is. It's the foundation, the data storage, the power grid, everything that supports the entire skyscraper and lets it scale up.
Let's start with caching. Really, caching is a simple but powerful idea. It's just about keeping the information you need most often in a super fast, easy-to-reach spot, like the computer's memory. So instead of having to go all the way to the main, slower database every single time, your app checks the cache first. It's the whole reason your social media feed seems to load instantly. That data was probably sitting right there in a cache, waiting for you.
Okay, but what happens when your database gets just ridiculously huge? That's where sharding comes in. Imagine trying to find one book in a library that has every book ever published all on one giant shelf. That'd be impossible, right? Sharding is like organizing that library by breaking it up into different rooms, or shards, based on something like the author's last name. It makes finding the exact piece of data you need incredibly faster.
So how do you manage those library rooms as you keep adding more and more books? Well, that's the problem consistent hashing solves. It's a really clever method that, in our library analogy, lets you add a whole new room for a new genre without having to completely reshuffle every single book in the entire library. It minimizes the chaos and disruption when you need to scale up your data storage.
Okay, just a quick heads up before we tackle our final concept. You might notice on the original graphic that number 12 is labeled sharding again. That's a little typo. But if you actually look at the picture and what it's describing, it's a totally different and super important concept called auto-scaling. So we're going to talk about what the diagram is actually showing.
And that concept is auto-scaling. This is the smart power grid for our digital skyscraper. It's always watching key metrics, like how busy the processors are. When traffic suddenly surges, it automatically spins up more servers to handle the load. Then, when things quiet down later, it gets rid of those extra servers so you're not paying for what you don't need. It is absolutely key to getting both amazing performance and saving money in the cloud. And there you have it. We've basically built our entire digital skyscraper. We have our front door to welcome users and manage the crowds. We've got the resilient backbone to make sure all the internal parts are talking to each other smoothly. And we have the smart engine room to power the whole thing efficiently. These concepts together are your toolkit for building just about any modern app.
Look, these 12 concepts are pretty much the language of the modern internet. This is the blueprint for building things that can start off small but grow to a massive global scale. So the only real question left is, now that you have the blueprint, what are you going to build?